Just like its existence, the birth of a star is a phenomenon, one that scientists continue to learn about as our space exploration technology continues to get better and better. But how exactly are stars born, and why are they important to us? Let's find out. The dynamic nature of the Earth and its enormous size means we're barely able to keep an eye on everything that's going on around us. In fact, our corner of the universe is a relatively quiet area that spans across 100,000 light years. Interestingly, this vast expanse of space contains around 200 billion stars spread across the famous spiral arm of our Milky Way galaxy. And it could even be more if the recent scientific estimates are anything to go by. So what makes a star? Stars consist of a couple of basic elements and forces, including gas, dust, and gravity. The dust involved in this process is made up of several microscopic mineral grains made of silicon, magnesium, iron, and apparently other metals, as well as including carbon in its various forms. According to scientists, the Milky Way galaxy is said to contain only 1 grain per cubic metre. However, there are quite a lot of spaces between stars. In the end, dust makes up approximately 1% of the total mass of interstellar matter, while interstellar matter itself constitutes roughly 10% of the entire mass of the Milky Way galaxy. On the surface, it looks like interstellar matter dust may be sparsely spread, but it sometimes clumps together and even forms dense clouds. The thickness of some of these clouds is so much that astronomers in the Inca Empire were able to group them into constellations. One of the closest clouds to us, the Taurus-Auriga clouds, are about 1,000 light years away, which makes it relatively easier for scientists to observe. For a fact, scientists have been observing stars and the elements that constitute them since the days of Aristotle. The Greek astronomer was one of the first reputable scholars to observe stars, describing them as objects that's nothing like any of the elements or objects that have been observed on Earth. And indeed, stars are a unique breed of astrophysical elements, but not in the way that Aristotle was thinking. Back then, Aristotle opined that stars could have been made from a substance called ether, which is evidently not true. His theory about stars spinning around in circles was also debunked once scientists realised that our Earth is a rotating object. These were the main points of discussion among the ancient star-studying astronomers and scientists. But suddenly, in 1572, astronomers spotted a new star around the constellation of Cassiopeia. At first, the brightness of this strange star dwarfed that of the other stars in the sky, but as days turned to months, the brightness continued to diminish until it faded into oblivion. Thanks to the advancement in space exploration technologies, we know now that this strange occurrence is the agony of a dying massive star. This singular event proved to scientists that stars have a life cycle when they are born and also die, just like humans. The telescope, one of the best science inventions ever, also helped to improve our knowledge about stars. The sophisticated lenses of telescopes completely turned everything around by giving astronomers a close-up view of distant objects. In fact, telescopes revealed to scientists that stars are actually farther away than we think they are. As scientists continued to explore, they began to find similarities between the outer worlds and our Earth, especially in terms of principles that regulate them. Sir Isaac Newton's law of gravity provided more insight into this belief with his law of gravity, which is applicable not just on Earth, but also on the Moon and other planets in our solar system. In the year 1704, Isaac Newton returned with another hypothesis in his book on optics that explains what stars are made of. Remarkably, Newton proved that white light is actually a combination of all the basic colours. In fact, his findings also taught us that all the colours it contains can be separated into a spectrum like a rainbow with the help of a glass prism. About a century later, English chemist William Wollaston improved on Newton's findings by passing sunlight through a narrow slit and then a prism. He found that the sun's spectrum had a few dark lines, but that was just a tiny part of the discovery. In 1814, German scientist and inventor Joseph Fraunhofer invented a machine called a spectroscope to measure the reflection of light through different types of glass. Using this device, Fraunhofer was able to detect even more dark lines that Williston didn't see in his own observation. The spectroscope would go on to reveal the true components of what the Sun's stars are made of. But critically, scientists needed to be able to interpret the hidden message behind those dark lines. Some pessimists, like French philosopher Auguste, never really believed in the ability of scientists to do this. In fact, he posited that chemical combinations of the stars might forever remain a secret to humans. But the telescope ensured that his prediction would be flawed. With time, astronomers began to combine spectroscopes with telescopes. English astronomer William Huggins was one of the first astronomers to try this out in 1862. William performed a series of experiments from his home-built observatory alongside his wife Margaret near his home in London. Their observation allowed them to record the spectra of many stars and other celestial objects. Among his target was the Great Nebula situated near the group of stars in Orion's belt. Huggins also discovered that the nebula's spectrum contains bright emission lines mostly corresponding to hydrogen. This was the best evidence yet that the nebula consists a massive cloud of glowing gas that could possibly condense to form new stars. After many years of doubts and theories, scientists found that the hypothetical situation was exactly the case. So, how are stars born? Basically, stars are born or formed when a giant cloud of dust and gas is stirred aggressively by gravity. During this process, adding more dust would result in a stronger gravitational force, which would consequently heat up the temperature and become even hotter. Once the components became hot enough, the resulting nuclear fusion reactions trigger the formation of a new star. Recently, scientists have been using three-dimensional computer models of star formation to predict that spinning clouds of collapsing dust and gas may split up into 2 or 3 blobs, which would eventually help to explain why the majority of stars in our Milky Way galaxy are paired in groups of multiple stars. So, what are the main sequence stars? Typically, a star of the size of our Sun would need about 50 million years to transcend from the period of its birth to adulthood. As they shine on for millions and billions of years through their lifetime, stars continue to burn energy in a process known as the main sequence. During this phase, the star attains a balance between the gravity that's responsible for making it shrink and the heat that causes it to grow bigger. Interestingly, the star is stuck in this phenomenon cycle until it runs out of hydrogen fuel. On average, fusion rates of stars range from a few million years for giant stars to about 13 billion years for small stars. The Sun's hydrogen burning cycle is estimated to be around 10 billion years, more than half of which has been expended already. Once a star exhausts the supply of hydrogen, it becomes a red giant. Many popular bright stars in the universe are red giants because they are luminous and not too common. On average, a red giant can be many times the mass of our Sun. In the end, the star's core begins to produce iron, which causes it to collapse. Depending on its size, the dying star could either become a white dwarf, a black hole, or a neutron star. Most stars, specifically small ones, become white dwarfs, while larger stars result in huge supernova explosions from whence it could either become a monstrous black hole or a neutron star. What do you make of the evolution of stars? Does it excite you as much as it excites scientists?